Hello, Clarity. How's this morning? It's been good?
Yeah.
All right. We'll try to keep it that way.
Yes. Here, you want to take hold of that?
Yeah.
All right. Well, thank you, everyone, for coming to Clarity. And thank you, Gina. There you are. The event has been amazing so far, so let's give a round of applause for Gina. So we're going to be talking today about designing standard systems. Now, just to give you a little bit insight of what that means is we've had the pleasure of moving into this world where web components has become a part of our technology stack.
Indeed.
And with web components comes a new way of thinking. And so today we're going to be discussing a little bit of our approach and how we have gone about providing a styling API for our web component framework. So I am Brandon Ferrua. I'm a principal UX engineer on the Salesforce Lightning Design System team. Stephanie we have been counterparts for how
4.5 years.
4.5 years now.
Yeah.
So basically what she does, I do, and vice versa. Great. And yeah, so we work under the Salesforce UX team, and we were one of the original co-authors of the existing CSS framework for the Lightning Design System, as well as our lovely host, Gina. But
brought us into this crazy mess.
And Stephanie?
Yeah, and I started out as an IC to architect the framework, and along with Gina and Brandon, and a couple years ago started managing the team that builds the framework. So we have 8 now that work on the framework team, which is super exciting, because we used to be a really tiny team. I'd like to know kind of who you all are. How many of you are designers? Okay, how many of you designers use some code? Cool. How many of you are front-end developers? Okay, pretty even mix. Managers, product managers, people managers? All right, very good. Hopefully we will provide some things that will work for all of you. As Brad said, this will be a little more of a technical talk, but we'll try to simplify it. At Salesforce we have this little design system, and we call it the Salesforce Lightning Design System. We like to just call it SLDS. It's a big, long name that marketing gave us. And it contains the same things most of you contain. We have a few differences due to our ecosystem, but we've got pretty much the same kind of system. And we started nearly 5 years ago building this version of our system. Since then, we've grown up a lot. It was, I guess, 3 years ago was the first Clarity conference, and Brandon and I shared the development of our design system and kind of the things we'd learned along the way. And we likened that progression of learning to crawling and walking and running, and then we kept running, and 3 years later we can tell you that sometimes you fall when you're running. And sometimes things change that are out of your control, and even your best laid plans can't really sustain you. So one of the things we shared last time was that you should know your ecosystem. And we still stand by that. It's really important to know exactly what's happening. And we knew our ecosystem. When I started 4.5 years ago, we had 67 designers, and we now have about 250. That is a lot. That is a big change. We've had a lot of acquisitions in that same time frame. We've got a lot of clouds within our system. And last I heard, we had 27 different stacks, different ways things are put together and being built. We also internally have thousands of developers. And externally, and this is where we're a little weird, a little different than some of you have to deal with, we have hundreds of thousands of external developers working for our partners and our customers, and they require differing amounts of, what should we call it? They want things to look the way they want it to look sometimes. It's not supported, but they'll reach into our stuff and they'll overwrite our classes. And then the other thing they do is they sell things within this whole ecosystem. They might put something on our App Exchange. They don't want to touch it for 5 years. And so we talked to you all about SAS deprecate, and we use it, and everything's marked up. All our deprecated code is marked up, but they've never let us pull it out of the monolithic CSS. Womp womp. So we still have all of that. So our ecosystem is odd because our customers build on this stuff too. But meanwhile, because of all of this, we needed to remain very agnostic. And what we mean by that is we've built blueprints. We don't build components. We build blueprints. They're HTML, they're CSS. They do not contain JavaScript. They do contain accessibility, where we can add it into the markup, or instructions for accessibility when people are adding JavaScript. And then engineers that are using it, they can write their own JavaScript. They can use a framework. We have a React project in-house. They can do it anyway. And that's fine. That's worked really well for us until now. So today, what Brandon and I want to talk to you about is what happens when your design system entire stack changes kind of out from under you. The rug gets pulled, and you fall like you saw the lady do. We did know our ecosystem. We've been using web standards in our framework, absolutely, but it's called Aura, the framework the platform is built on, is proprietary. And this is why it's changing, because our architects decided to move to web standards, meaning web components. And this will allow us to have a much more performant framework, because in time, bit by bit, we pull out our polyfills and the browsers will do the heavy lifting. And this makes it so much better in the end. So one of the principles and methodologies we've been using for styling, though, those things don't work as well anymore in the web component environment. These are newish specs from the W3C, and they have some interesting effects on CSS. Now, as you all know, does everybody like the global part of CSS, the global cascade? Who loves it? Well, I love it. But how many of you don't love it? Oh, be honest. I see you all bitching on Twitter all the time. I see this. And what I hear is that you all think the C in CSS stands for conflicting, stands for confusing, stands for colliding. So you'll be happy to know, for the most part, with web components, you'll get rid of most all of your global cascade. Aren't you happy? So, I'm getting ahead of myself, though. Let's first look at a brief overview of web components. So, I'm just going to share the portions that are important. We're not teaching you how to build a web component today. In a moment, Brandon will take you into the specifics of how we are currently implementing this within our own design system. Your mileage may vary. But web components are comprised of several specs. And for the purpose of our discussion today, we'll define web components as an encapsulated DOM tree. We'll just leave it at that. So this means your component can be taken anywhere. It will contain the CSS, HTML, and JavaScript it needs. And because of that, it doesn't interact or interfere with the environment you place it in. And that's really the thing that many, many people love about them. So there are custom elements, shadow DOM, HTML templates, which contain slots. We'll talk about that today, and HTML modules. Now, we're not going to talk about HTML modules today, except to say they provide a way to include HTML, JavaScript, and CSS in another HTML document. And that spec has gone from being ES modules to HTML includes to now, today, HTML modules. We'll see if it stays that way. Finally, is there a styling API? Well, not really natively, but what we're going to share with you today is the things that we are going to use to create our own styling API. So first, let's look at custom elements. So the custom elements spec allows you to design and use new types of DOM elements. So do you remember when HTML5 started and we had like all those new named elements? It was crazy. Well, now you just get to make your own. You can name it anything you want. You may have seen them when you're inspecting a page like YouTube to see what YouTube is up to. Custom elements all over the place. You can create them with any name you like, but as we learned at the first Clarity, naming is hard, y'all. It's a theme. You'll want to use a name that is unique to you, so guess what Salesforce uses? Lightning, because we call everything Lightning. Anyway, if you're using multiple words, you'll want to use dashes. You can't use spaces or underscores. And in our example, you can see we're opening with a div that has a class called context. And then you create, following that, we've created our custom element. It's called Lightning Foo. And you have to register this new element so that the browser knows that it exists. And once you do that, you have everything you can do with any other element available there. You can attach event listeners. You have access to the entire DOM API. But these custom elements, as you might imagine, can cause some interesting things in CSS. Because it's a DOM layer between the div context and the div myComponent, we can no longer use things like child combinators because that is not a direct child. There is now this DOM layer in between. And similarly, when we're targeting adjacent or general siblings, those will fail selector matching because you're inserting a custom element. However, you can use those kinds of selectors within the custom element where you own all the things. You just can't use it outwardly and expect it to match. So let's look at some things we need to remember about these. One of the first things we discovered when we began our implementation was custom elements are initially display inline. I was not expecting that for some reason. I don't know why. So you may need to change them to be display block, display inline block, whatever you need that element to behave like. However, if you're using Flexbox and you want to target the inside of your component as the children of your Flex parent outside, you'll want to set that display property to display contents. And all that does is essentially make the custom element invisible. It passes through, and it allows these children to see their parent and to interact as you would want them to. You will lose predictable combinator matching, so you need to be really mindful as you compose your components. And then when a custom element is registered, the HTML element appears in the light DOM, and it wraps the internals of the component. Anybody ever heard of light DOM? Light DOM. Oh, a couple hands. So light DOM is a new word, right? And let's just talk about what that actually means. The Shadow DOM spec defines how to use encapsulated style and markup in a web component. That's the Shadow DOM. The light DOM is simply the regular DOM we've all been using all along. It's not in the encapsulated area. We've just given it a new name to confuse you. Just, make it seem a little harder. Enabling Shadow DOM is not required for it to be a web component. You don't have to do that. But, and in fact, YouTube doesn't do that. But it provides a mechanism to encapsulate the DOM tree, so many people really want to use that piece. So let's look at what this looks like in code. Now, before your eyes glaze over, I broke this slide down because I couldn't make it where it wasn't confusing. So let's see if I've achieved it. So we've registered our custom element. The browser knows it exists, and everything inside it is in the light DOM. Your whole everything in that custom element, light DOM. Now, the shadow is not some ghostly creature haunting our component. It's the element we insert to handle the encapsulation. So, and not everything in your component needs to be encapsulated. In our case, we can use JavaScript or an HTML template to insert the DOM node, which will be the div myComponent, the class myComponent. We're going to insert that into our shadow root. That will be the only thing in our shadow root. So you can see where it begins. Puppies and kitties, we had to do it. Where it begins and where it ends, and where that shadow root ends is called the shadow boundary. Simple thing, but there's no close. When you inspect, you'll see shadow roots and native inputs and text boxes and things that come from the browser. You won't see the end of it. You'll just see the shadow root notation. But the end is where everything that isn't in there, the shadow boundary is the end. All right. So the element we attach the shadow root to is called the shadow host because it's hosting the shadow root. So that's fine. And that's our lightning foo. That's where we've attached our shadow root. Finally, everything else remains in the light DOM. So because we only put the class myComponent div into the shadow root, everything else that we might have in this component is in the light DOM. Did that make sense?
Yeah.
At all? Are your eyes just...
Of course it did.
Yeah? Okay. All right. So this changes the way we deal with CSS, as we mentioned. Global CSS will only reach elements in the light DOM, but it will still reach those elements. So notice we have an H2 that occurs prior to this custom element that is bound by our shadow root. That particular H2 can access the global cascade. So our regular H2 selector will match. But due to encapsulation inside the shadow host, you can't match any external global CSS. You can target it, you can add classes for context, you can add important, and if it were z-index, you could add 1,000,000. It wouldn't work. It wouldn't help. It doesn't match. One way you can add styling is to inject scope styles into your shadow root. These will match. So for example, you can add a typical old style block within your root, and it will match the H2 that is inside there. You can also inject a constructible style sheet. Brandon will talk about that later. We'll leave that be right now. And here are a few things to keep in mind when you are using shadow. You have encapsulation, like I mentioned, nothing gets in, nothing gets out. This includes your CSS. But it also includes your accessibility. And so the accessibility object model is not yet fully developed. And at Salesforce, we are fully into everything's got to be accessible. We will not actually turn on shadow root until this accessibility piece is worked out and we can make all our components accessible. We will still use all the other things we're using, we just won't turn on shadow root. The only way to cross the shadow boundary is through CSS Custom Properties and constructible style sheets, which are coming up. Now, let's talk about slots. These are part of the HTML template spec. This is the only piece of it we're going to talk about. But slots are a safe little space that you can put anything into. They're essentially placeholders inside your component. It's where you think your customer using your component might want to put content. So if you had a card, you might have a slot in the header and a slot in the body and a slot in the footer so that people can put in whatever they want. Now, they're placed inside the shadow root, and it's a simple little slot element. You can see you can name them if you need to, if you're going to have several. You don't have to name them. The browser will put the content into that slot regardless. So in this example, I've got an H2 followed by a slot, and let's see how that looks visually. So there's my component, H2. There's my slot that says Hello Clarity. And you can see that when I authored this component, I'm authoring my lightning foo, and then I just put Hello Clarity in there. I'm putting just a paragraph, and that is me as an author putting it in there. It's sort of like React. Anything that you want to, you can put into a slot. You know, it's like React Children. So the markup of your component goes into the slot, but it's contained in the light DOM. And I know that seems weird because we just saw it visually rendered where the slot was, right? However, when you're actually in the DOM, this is what you're going to see. The browser will not mix the light DOM and the shadow DOM together in the same DOM nodes. It keeps them separate, but it visually renders the content for your slot right where your slot is. Weird, right? That one took me a long time to comprehend. And since the content of the slot is outside the shadow and actually in the light DOM, can you even style it because it's not in your shadow root? You can. You use the slotted pseudo element, and it will target the content in your slots. This selector is targeting the P element. You can also write it to target a named slot. So any name, you can target all the things. Let's look at the things we need to remember about slots. It's, like I said, rendered visually, right where you put it, but in the DOM, it's in the light DOM. You can target compound selectors. So the way we targeted the P, we could target any selector we want to in there. But it can be a little unpredictable if you're getting into things like nth child. Slots can be uniquely named, so you can have them all over and specifically target and add the information. Now I'm going to turn this over to Brandon's capable hands to talk to you about the styling API we're creating to decorate these lovely web components.
Awesome. That was some great stuff, Steph. So that's the Shadow DOM. Good luck. No, but seriously, that styling API piece that Steph was talking about, that's what I'm going to be discussing here today. I want to take everyone on a little bit of a trip. We're going to be talking about some of the highlights and approaches that we at Salesforce have been taking to tackle some of the pitfalls of the Shadow DOM that Stephanie just brought up. Most of the examples that you're going to see here are going to be quite specific to our problem space. So it's really about styling very large enterprise applications, right? But hopefully there's some useful information that you can take away and apply to your own design system. Just a real quick disclaimer before I get started. I'm about to get in some rather dense stuff right now. I'm going to be providing specific implementation details, as well as talking about some concepts, some like high-level stuff. Where's Denise? I think we need some of that jungle LSD. Where you at? Anyways, we can take that later. All right, so we ready? Okay. Yeah, let's do it. Okay. All right, let's do this. So, since we're at a design system conference, I want to talk about design tokens. So hopefully most of you in the room understand the value of a design token. They help us provide application-wide consistency of our visual languages, right? So, but they're also a fantastic way for us to communicate our design decisions within our code. All right, so for those of you that aren't familiar with tokens, here's a very simple syntax example of what a token is. So the syntax is very simple. It's just a key and a value pair that's going to store a design property. All right, so these are typically generated by design system build tools. So we have our own at Salesforce. It's called Theo. It's going to take a single source of truth, and it's going to generate all of these key value pairs in platform-specific formats for us. So if you've ever used a preprocessor like Sass, so it would generate a Sass variable like you see up here on the screen, and then I can just use it directly within my CSS files. Okay. So over the years, we at Salesforce have actually been trying to take a step back and thinking about thinking and iterating on how we can better categorize how we communicate tokens. And we realized that we really needed a way to separate sets of tokens from the ones that communicate our visual language and the ones that are our customization layer. All right, so that layer that's going to communicate our visual language is something that we're going to refer to as primitive tokens. So we host all of our primitive tokens within a separate GitHub repository that any project within Salesforce can use as a dependency. All of our primitive tokens are really just an abstraction of our core visual language, but they really help us align our brand across systems of systems, okay? But there's a couple key attributes that I want to point out with primitive tokens that might be different from the second layer that I'm going to discuss here in a bit, is they're actually not customizable. Like, don't assume, they should never change after they are rendered, right? Like what you see is what you're going to get, so you're going to store those values as you want them within that repository. And they're also systemized to scale. Scale, what are you talking about? So what I really mean by that is like they just come with no assumptions. of how they're going to be applied within the system. But really, the key attribute of them is that they're semantic by nature. So that how we're going to use the semantics is really going to tell us how and when we should use these design tokens, right? So those semantics are communicated through the way that we name our tokens. So at Salesforce, we like to use these 5 categories to describe the semantics of our tokens. So we have category, property, an attribute, a relationship, and a state, okay? So these are prescribed within this order, but they can actually be used in multiple combinations with one another to establish a consistent way that we author our tokens, thus establishing a consistent conversation with our designers and our engineers. All right, so an important piece to take away from this is it's really all about maintaining a sound classification system too. And this is where I want to focus on that very first piece is categories. So categories are a group of similar classifications of tokens. So your categories are really up to you and your team. This just happens to be what we like to use. And what it should do, it should really describe the rules of your system. Now, some of the categories are going to be more robust than others. You'll probably have a bunch of color properties that are associated to, yeah, you get it. So, but really it's up to your team, but really the goal is going to remain the same. And I think it's something that we should all be striving for when it comes to code clarity. It's something that I like to communicate to our internal teams, is really it should be providing a sound classification system to your system. Now, with primitive tokens, I feel like it could take us pretty far with driving alignment just by taking these things that I've talked about and just using them directly into your code base. But what about that layer for customization that I was talking about? So this is where the component token layer comes into play. So this is where we can take advantage of the component scope and we can tweak values that are specific to only that component, all right? It's the layer that we can use to declaratively expose properties that we want to allow customization on. Now, since theming and customization is a requirement of our design system, we want to enable our customers to take advantage of this API exposure to allow them to tweak things like typography, colors, maybe add some unique interactions, and it just helps them better communicate their brand if they were to use our design system. Now, we see this as our control layer, right? So what I mean by that is we actually have full control of how we want that component to work. Do we want that property to inherit just a primitive token value? Do we want that to expose a new API touchpoint that a customer can take advantage? It's really up to us, and those are the kind of conversations that we have with our developers and designers about what should this thing do. Now, as for the semantics of a component token, really the only thing is the fact that we're going to denote it with a unique prefix that says that we're going to be using a component-specific token, right? So if I see this in the code base that says, hey, I'm probably going to change at some point. Now, this is expressed by just prefixing all of those naming groups with a C followed by the component name. It's pretty straightforward. So now that we have tokens covered and out of the way, I want to move into another category and talk about their cousin, CSS Custom Properties. All right? So who here likes to read technical specifications? All right, I have a really good support group. It's called We're Going to Get a New Hobby and Probably a New Life. But I am one of those, so I find there's a lot of insight into the way that these browser implementers are authoring these technical specifications. There's critical keywords that I find that I can take out of those and actually apply to some of our architectural decisions in how we build our design systems. But anyways, let's get into this really long definition here, shall we? All right, so what is a custom property? So custom properties are author-defined properties Okay? They allow arbitrary values to be assigned to an author-chosen name. They can be, when inside of a var function, it allows that custom property, okay, that new author defined name, to be used anywhere or elsewhere inside of your documentation. All right, so I know that was a lot, but I really wanted to just focus on one aspect of this. I want us to focus on the elsewhere aspect of this definition, and just keep that in mind throughout this conversation. Because as Steph mentioned, with the shadow DOM limitations, elsewhere isn't really a thing that comes easy to us. All right, so for the syntax of a CSS custom property, it kind of looks like this for those unfamiliar with it. The top example is our CSS property declaration, kind of like those design tokens I was talking about. It's just a key and a value pairing. And then to use that CSS custom property, you're simply going to wrap that in your var function, and then you're going to point it to the author-defined custom property name that you had. And then it will also accept the second parameter as a fallback if you choose to do so. So when talking about styling web components, I kind of want us to just breathe and pause for a second, because it's kind of already been a lot. But I want us to focus on two concepts, all right? Just two. There's a lot more, but we're just going to focus on two. So the first one is scope. A CSS custom property must always be defined within a scope. Now, a scope is really just the pseudo element in which we're going to target inside of our CSS files. We're going to focus on 3 levels of scope. And I'll be covering that here in a little bit. Okay. In the second, something I want you all to keep in mind is a CSS property can actually be in your code base and defined with no initial value. And if I talk about this later on in the conversation, let's just refer to this as a placeholder. All right. So let's touch on the first item, scope. All right. So where is my scope? So like I mentioned, to ground us, we're going to focus on 3 logical scopes. The first one is going to be root. All right, so it's the HTML element that represent the root or top level of your HTML document. All right, so let's say we have our web application. Like all HTML documents, they start with the HTML tag. Surprise. This is our root pseudo element. Okay, it's available to our entire application. So now that we know that, we can simply scope a CSS custom property to our root pseudo element. And basically what that means is all of these CSS custom properties are available to anything that's inside of that web application. So from there, I can simply use it as a reference point inside of my var function, like we mentioned, inside of any component, and it will just pick up that value that is applied to root. So in this case, my component is going to have a background of badass, because why not? So next, let's talk about scope. All right. So scope is the HTML element that contains our components shadow DOM and light DOM. Now, most web applications are composed of many components. So what does that mean? That probably means we have many host pseudo elements on our page. But I think the unique thing about this is host, just that pseudo element, is scoped to just that component. So no more do we have to be thinking about, okay, what CSS scoping tool are we going to use to auto-generate some weird computer readable name onto my component, and then so I know that my styles are scoped. No, you can just use host. Right? So with host, same thing, same concept applies. You can have your CSS custom properties that are scoped to your host, but the unique thing about that is I can only use that inside of my component. No one else has access to that. So now, fundamentally, how this applies to our real world, hopefully I'll get to an example that highlights this, but really the thing to take away is just those things now have ownership to that component. All right, so now let's move on to our last scope. This might be a little bit dense, so bear with me. So our last scope is I'm going to refer to as context. So you might find yourself in a situation where you have a component and you're using someone else's component and you don't like the way that that component looks, right? This is where you're going to use context. so that the component is really going to be contextual to the environment that it's going to be living in. So context is really just the selector inside of the host scope that you have ownership over. So think of, we always like putting grand metaphors on things. Say you're a homeowner, right? And you want to paint the walls in your house. I want to paint all of my walls blue, but then my wife wants to paint the guest bedroom pink. So the guest bedroom is actually the context to those walls being painted. I'm only going to be changing the things inside of that guest bedroom. All right, so just you can think of it like that. It's an identifier. It's the ownership of what's being changed. So since at Salesforce we have a requirement to tweak styles when a web component might find itself inside the context of another web component. So here, if we have an application, I can use context as my scope to change another component's styles. So in this case, I want to change the styles of this child component when it's inside of my tabs component. Okay, but there's one unique thing for this to actually work, is that child component needs to have an exposed CSS property for us to extend upon. Once it has that property exposed that we can extend upon, we can use our context scope to change the styling of that child component. So here, in the example, when inside the context of our tabs, I'm going to change this background to badass. Now, in a world where shadow DOM encapsulation does not exist, it would actually be the same thing as writing this selector right here. But we're doing it in more of a declarative way, right? So now that we covered a little bit of like the 3 levels of scope that I was talking about, okay, we might need to take a deep breath right now, but ready? Okay. I'm going to dive into the power of placeholders. So like I mentioned previously, if a CSS custom property does not inherit an initial value, we're going to refer to this as a placeholder. Now, just another disclaimer before I move on. This is a concept that we at Salesforce use internally. If you're a pro Googler and you're like, what is that thing is he talking about? You may see it referred to as like a styling hook or a free variable. But we like to refer to them as placeholders, to each their own, right? So what do placeholders provide us? Well, I think what they do, like the power of them, is they help us keep the integrity of our design system intact. So let's take a look at this example. So we have a class inside of our web component called myComponent. And then so we're going to use that scope to actually expose this styling API to anyone else for them to use. So if you look at how this syntax is structured and you take a step back and you think about it, that first parameter should always be your styling API. It's a blank placeholder. No one's using it. No one has ownership. Well, the component has ownership over it, but you can use it how you want. And the second piece should always be your design system. I know, right? So that second parameter is typically a value that comes from those things that I talked about earlier, the token sets, those primitive tokens, those things that define your visual language, those things that don't change. Okay, this allows you to make sure that if no one takes advantage of extending upon that styling API, you will always have your design system to fall back on. So we can take this further through a concept that we refer to as assignments. So this is how we refer to our internal development of components. And it's really a way for us to explain how the styling API can be extended and what context your component is inheriting styles from. All right, so that was kind of a lot to digest, but hopefully you'll follow along here. So first, I want to talk about this concept of a closed assignment. Switch. There you go. So a closed assignment is an approach of controlling how far your component's API can be extended. All right, so if you just take a simple example, let's think of a button. Now, you probably have a button. It's white, but it has a white background by default. It comes with placeholders that we can use to extend upon, but within your design system, you also have a brand variant of that button. Now you've already written all this awesome CSS for your default button, and you really are only changing a couple colors to get your brand variant. So what we're going to do is we're going to expose a couple of those properties as CSS Custom Properties for our variant to take advantage of. But a unique requirement of this brand button is that it always needs to be branded with our color. We don't want anyone changing it. So this is the point where we're going to allow no customization beyond this variant. So this is where we would use a closed assignment by reassigning the CSS custom property that is in our default button and using it inside of the context of our brand variant as a closed assignment. It's basically saying you're always going to be brand and you're always going to be blue. All right? But then we can use this concept called an open assignment. So an open assignment is saying that the requirements of your design system allow for that flexibility. You want to allow your customers to extend upon variants of variants. There's this. It's a little bit more complex because there's more that you need to follow when it comes to inheritance. But really, this is how we would use an open assignment. So the way that we do this is it's accomplished by taking the CSS custom property that is in our default button, reassigning it to another CSS custom property that is in our brand variant, and then really the only difference is we've just changed the name of that new custom property that's in brand variant. So you'll see C button color background is in our default, and you'll see that is reassigned to C button brand color background. So I'm saying go ahead, I just made a new API for you, do whatever you want. Now our customer can basically take that component and they just need to look at what are the exposed API touch points, provide their scope, and then reassign it to values that they want, right? So that's pretty cool. You're really providing a new level of power to your design system without even messing with the integrity of your core design system. You're not going in and adding special snowflakes. You're just exposing things and letting really people add their own special snowflakes. It's just not your responsibility anymore, right? So with that, a couple things I want to mention. Now that we have all this power at our fingertips, and we all know that with great power comes great responsibility. So there's a couple things that I just want to point out and call out as we move into these new uncharted territories. The first thing that I ask is, as an engineer working on the styling API for your design system, it's our responsibility to document your API. We've come from a world where, especially with the global cascade and just handing off components, that things would just work. But now we're moving into a world where things are a little bit more explicit. So we have to take the onus of documenting all the stuff that we do. Now, your API that I just kind of highlighted at a very high level should be the thing that describes your guardrails of your design system, right? We now actually have a tool where I can tell a component what can and cannot be changed. I think that's pretty cool. And then CSS development in a world with Shadow DOM, we're actually going to start, is kind of touching on the first point, but we're actually going to be shifting our focus to writing more explicit APIs away from the world that we lived in, working with implicit APIs. So what I mean by that is now it's on us to have that control of how people use our stuff, right? So it's gonna start being this mind shift of how we have to start looking at the web if we think about working in web components. Okay. Please be deliberate about what you expose. And what I mean by that is we're actually going to we want to start treating this as a true API, right? Don't expose the things that you don't want to be changed. You can have that discussion with your team. You can set the rules and the boundaries with your team about what you want to change and why you don't want certain things to change, right? But just know that if you do expose it, you are responsible for supporting it for the unforeseeable future because you are now working with a true native API of the browser. So as everyone in this room knows, your design system is a fantastic communication tool. And so this is, like I mentioned, this is a fantastic opportunity to use this tool of code as a primary source of truth for how your design system should work. Okay, systemize your rules and apply them in code. It's only going to help strengthen those conversations that you have with your designers and your developers. You know, if something isn't exposed, hey, I want to change this. Well, actually, we can't because of X, Y, and Z. We've already had this discussion. Or maybe it's, you know, we can have that discussion of what can we do to get you to a point where this thing does become exposed? What kind of buy-in can we get? So lastly, I want to cover, thank you for bearing through all that with me. Next, I want to cover a new API that can also help you achieve your styling goals called constructible style sheets. So constructible style sheets is a fantastic way to give your design system a little bit of that extra performance boost, because really that's what it was built for. But as a side effect of that, it can actually help us leverage a migration path for the teams to move into this new way of doing things without just going full haul into it. All right, so what is a constructible style sheet? Really, it's just a way to create and distribute reusable styles when using the Shadow DOM. All right, since the Shadow DOM took away our cascade, we have to inject CSS into our web component Shadow DOM. And this is accomplished by using a good old style tag, or it can be done in a performant way using constructible style sheets. So what is constructible style sheets and what makes it performant? Okay, so let's say we have a simple application like this. You know, there's many web components within our page. You may notice some similarly colored blocks within this application. You know, that's probably an indication that those web components are using identical CSS. Now, the problem with injecting a style tag into each one of these web components is that you're sending identical CSS over the wire for every single web component that's being registered. Okay, so that's where constructible style sheets is going to help solve this problem. So this is an image from a Google article that I thought highlighted what was happening very well. So constructible style sheets, basically all it does is creates an instantiation of that authored CSS that we already have and creates a reference point for it. And then each one of our shadow DOMs can actually use that reference inside of our shadow DOM. So what do I mean by that? So basically, instead of sending multiple requests of that identical CSS, that gets brought down to one single request for 4 web components that are registered. I don't know about you, but I think that's pretty damn awesome. So this technique, along with a sound caching strategy, can increase the performance of your application. Now, with performance aside, this could actually also help with a migration problem that we have. So we have a lot of customers, like we mentioned. We have a lot of customers doing weird stuff, like we mentioned. We have a lot of customers writing CSS that makes their buttons pulsate. Now, the customers say, oh, it's an attention grabber. You know, but I really think that this falls under that super annoying category that Val mentioned yesterday. But so it just sits there and pulsates. Now, the thing with this is there's when it comes to animation, keyframes, very timely, structured animations, there's a lot of CSS, manual CSS that needs to be written, right? And there's no way that we can expose all of that through an API touchpoint. So really, what can they do? So the customer has written this CSS, and they say, I want to use your new web components, but I don't want to do all that stuff that you were just talking about. That was weird. All right. Well, they can use constructible style sheets. So constructible style sheets is this thing that we're going to use where we're going to take advantage of this thing that each shadow DOM has called an adopted style sheet. Basically, it's just an array. Okay, so because it's an array, we can push new CSS to this existing array that already has CSS built into it. So the design system that we ship, it already has our design system button inside of that constructible style sheet, or that adopted style sheet, okay? And then we're gonna construct it with the customer's CSS by pushing their CSS into that adopted style sheet, and now they have our design system CSS, as well as their CSS that they've written. They haven't touched any of their code, and it still pulsates because the normal cascade still applies. And now that customer can sleep well knowing that they are on this latest technology with their pulsating buttons and all, without writing a single new line of CSS.
At least they're not giraffes.
I think they would be better if they were, to be honest. All right, so the best part about all these things that we've discussed so far is they're actually available to us. Like, most of the stuff that we talked about is implemented and shipped in major browsers. Now, if you have support for IE11, you're still going to have to rely on, there's a lot of awesome web component frameworks out there. We have our own called LWC, Lightning Web Components. Or there's, you can polyfill it, which are all publicly available. Now, but speaking of the future, I just want to touch on one last specification proposal. Now, the standards bodies working on web components has proposed these two new proposals, part and theme. Now, these specs are in various stages of discussion, acceptance, and implementation. So really what it is a declarative solution that is going to allow the HTML author to target specific elements inside of their shadow DOM, but not all of them to allow styling. So really what this does is everything that I've discussed, the onus of the styling API is on the CSS author. So this is going to shift it back to the HTML developer. So the onus of exposing that API is on the HTML developer versus the CSS author. Okay, but we feel that with constructible style sheets and CSS custom properties, that API can continue to remain in the hands of the CSS author. Now, this might not be the case for everyone, but because of our unique situation at Salesforce, because we build on a platform, people build on top of us, and people build on top of them, and it just keeps going and going. We have decided that it actually makes more sense for us to keep the ownership of that styling API in the hands of the CSS authors. Mainly because of that situation where HTML is built, it's sent away, and you'll never see it again, ever. So, but this is still in the works. It may provide some value for you and your design system, depending on how big and what kind of problems that you're trying to solve. But really, what it does is it draws me to another point, is where this is an opportunity to allow us to help lend a hand in all of this. These are ongoing discussions that are happening daily. All of these issue trackers are on GitHub. Everything is publicly visible. I think that there's a bunch of other stuff with like bug trackers and everything. So you can actually see the discussions that these browser implementers are going through. And they actually want our input. So this is an opportunity that the standards bodies working on these specifications are looking to us to help shape those APIs. Like, have you been using them? Do you have a use case that you think fits the mold of this? Have you maybe been using one of their Canary APIs and ran into some problems? I would encourage everyone to go ahead and post inside of their issue tracker. Get involved, because it will only help make the web a better place. Because ultimately what we're trying to do is we're trying to shift some of the problems that we've run into, where we've come up with all these awesome solutions, but all those awesome solutions are in frameworks, nothing against frameworks, but native is ultimately going to be better, right? Let the browser handle all this stuff for us. So I want to just recap real quick on some of the things that we talked about. So first is, keep an eye on your ecosystem. Watch your ecosystem. This whole web components, shadow DOM thing, this might not work for you. This made a lot of sense for us, even if we wanted it or not. But it's just watch your ecosystem. Understand who your customers are, what are the needs that they have. Shadow DOM is going to block your global cascade. So the time is now for us to start shifting our mindset if we're going to move into this world of how we approach building the web in a more modular way. Treat your CSS APIs like any other web API. Document, document, document. I can't stress that enough. And if you want to use Shadow DOM, just a reminder, please keep an eye on the browser's implementation of the accessibility object model. Like Steph mentions, we will not be turning on Shadow DOM until this is resolved, but the more pressure use cases that we provide to the standards body, the quicker that we can get this in. And then playing off of that, the standards-based implementation is going to ultimately push the web forward, so please get involved. Here are some resources that I wasn't able to really get into detail about, but that I find quite interesting as they relate to the Shadow DOM. There's a new proposal by Microsoft based on the CSS module proposal. Basically, no more of those Webpack style loaders, all that type of stuff. The browser is just going to let us import a CSS file into our JavaScript. That's pretty cool. Here's the explainer on constructible style sheets. If you want to learn a little bit more about that. I've included the part and theme explainer, so if you want to deep dive into that, maybe like grab a huge cup of whiskey before you get into that thing. And then again, the accessibility object model. That's kind of a tracker of current status, current explainer, spec implementation, and such. So with that, thank you very much. If there's any further questions, we are more than happy to discuss after this. That was a lot to take in, but we want to thank everyone for their time.
Yeah.